A 0.2 kg object moves along a straight line. The net force acting on the object varies with the object's displacement as shown in the graph above. The object starts from rest at displacement x is equal to 0 and time t is equal to 0 and is displaced at a distance of 20 meters. Determine each of the following. A. The acceleration of the particle when its displacement x is 6 meters. B. The time taken for the object to be displaced the first 12 meters. C. The amount of work done by the net force in displacing the object the first 12 meters. D. The speed of the object at displacement x is equal to 12 meters. E. The final speed of the object at displacement x is equal to 20 meters. Let us do the problem. Here, the graph is force versus displacement. The displacement is given along the x direction, along the x-axis, and then force is along the y-axis. Now, he is asking us to find out the acceleration of the particle when displacement is 6 meters. When the displacement is 6 meters, what is the force? Force is 4 newtons. Therefore, we use the equation, Newton's second law equation, F is equal to ma, and then we plug in the values and find out the A. Here, force is 4 newtons, and then mass is given as 0.2 kilograms. We can easily find out A is equal to A value, and which gives 20 meters per second square. Next, B bit. The time taken for the object to be displaced the first 12 meters. To displace the 12 meters, how much time is required? That is the question. So for that, we use the kinematic equation. D is equal to VAT plus half AT square. Here, he is asking us to find out the time to displace 12 meters. So displacement is given as 12 and initial velocity is 0, when t is equal to 0, vi is equal to 0. So here we plug in that value plus half a value we already found out as 20 meters per second square. We have to find out t value. Plugging in these values, we get t is equal to 1.1 second. Next, C. The amount of work done by the net force in displacing the object the first 12 meters. How much of work is done by the force in displacing the object first 12 meters? So work done is equal to force into displacement. We know the force is equal to 4 newtons and then displacement is 12. Work done is equal to F dot D is 48 joules. Next, the speed of the object at displacement x is equal to 12. This is based on the work energy theorem. Work done is equal to kinetic energy. Suppose work is done on the object, that amount of work is stored in the form of energy, or work is done by the object, then the stored energy will be released in doing Okay, that energy will be released in doing the work. So here W is equal to half mv square. Here it is the kinetic energy. And then the work done we already calculated as 48 joules. That 48 joules is equal to half mv square. And then we know the mass as 0.2 kilograms. We have to find out V, velocity. So plugging in the values, we get velocity is equal to 22 meters per second. Next, the final speed of the object at displacement x is equal to 20 meters. So to find that one, we have to calculate the area under the curve. Area under the curve gives the work done by the object. So here, the area under the curve means we have to calculate the area of the rectangle and also the area of the triangle. Area of the rectangle is length into breadth, whereas the area of triangle is half base into height. Let us see what is the area of the curve. Total area gives the total work done. Now, the area of the rectangle is length is 12 and then breadth is 4. So 4 into 12 is equal to 48 joules. And then the triangle, the base is 20 minus 12, 8. And then height is 4. So work done is equal to half base into height. Half into 8 into 4 gives 16 joules. Total work done is equal to 48 plus 16 is equal to 64 joules. Now this is 64 joules is equal to kinetic energy. So 64 is equal to half mv square. Therefore, v square is equal to 64 divided by 0.1. When we plug in the values, we get this value. And then final velocity v is equal to 25.3 meters per second. So the entire problem is an integrated problem or multiple concept problem based on the graph. Once you learn how to read the graph, then it is easy for you to do the problem. That's it. Okay. Thank Thank you. Bye-bye.